Hello everybody. Today we're going to work on the second part of Algebra 1. Usually this part is called properties of real numbers. This chapter or this class will include everything about it you need to know about real numbers, like what is the real number, and plus, minus, multiplication, and division, and also the square root, these operations of the real numbers. And then we also will learn the LCD, the least common denominator, and those kind of information. So let's start. The first thing we need to review a little bit is the absolute value. Absolute value. Okay. The absolute value is the, before we know absolute value, let me show you. This is the number line. You probably have learned this. This is the number line, and here's a 0, here's a 1, and a 2, and a 3, and a 4, and on the other side we have a -1, -2, -3. Okay, so if I ask you a number, can you mark the point that has the value 2.5? Can you do that? Yes. If you can find a 0, 1, 2, somewhere between 2 and 3, it's right in the middle. So here is the point. It shows 2.5. But if I ask you what is the absolute value of this 2.5, what I'm asking is, what is the distance between this point to the origin 0? So I'm asking about how long is this. So you can tell the distance between these two. The distance is always positive. So 2.5 absolute value is 2.5. Okay. So what about -1.2? Now you already see that I have this 2 bar, and I put the number in the middle, or the amount or the value in the middle, and that is called absolute value of this number. So in this case it's -1.2. So here is 0, then -1, -2. The -1.2 is somewhere here, right? This is the -1.2. And then if I ask you the absolute value of -1.2, I'm asking you the distance between this point and 0. So that's this. All right, and that absolute value is 1.2. Now let's see what can you tell from this. When we talk about the absolute value, we talk about the distance between that number, between the point to show that number on the number line, and 0, the origin point is 0. So the distance is always positive, which means the absolute value is always positive. So we can find the absolute value of 100 is just 100. And the absolute value of -5, that will be just a 5. Just take the number part. Okay, you only want the positive result. And what about the absolute value of 0? That is just 0. Okay, so this is the very basic about the absolute value. So that's the first thing we want to review. All right, then there's another concept. It's called opposite number. Opposite value or opposite number. Okay, what is the opposite value of 5? What is this? If you have this number line, Here's a 0, 1, 2, 3, 4, 5. And the other side you have negative 1, negative 2, negative 3, negative 4, negative 5. Okay, here is a 5. If I ask for the opposite of that, I'm asking for the other number which is opposite to the 5 among this 0. So that goes to here. Okay, so you can see the opposite of a 5 is negative 5. Right? Now what about the opposite value or opposite number of negative 3? Here is negative 3, right? So what is the opposite of negative 3? And that goes to this side. So there would be positive 3. Or you can just write 3. Now you can see that when we talk about the absolute value, we just change the sign in front of that number, because the opposite of 5 is negative 5, the opposite of negative 3 is positive 3. So that is the opposite. So we get the idea about the number line. The dot shows the value, and we learn the absolute value and also the opposite. Now, two opposite numbers have exactly the same absolute value, isn't it? We have the absolute value of a 5. That is the same as absolute value of negative 5, and that is 5. And also we have the absolute value of negative 3, which is the same as the absolute value of positive 3, and that is a 3. See, this is a very good property of the opposite value. All right? Okay. All right, the next topic we need to work is a square and square root. Square and a square root. All right. We use this little symbol to show the square root. Okay, so we know this. We know 5 squared is 25. We did this last time, right? And then we also know 8 squared is what? 64. 8 times 8, 64. Okay, 5 squared is 25. Then the square root of 25 equals 5. Okay, if I give you this notation, square root of 25, then you're looking for that number. It's a positive number and its square is 25. So that number is 5. But if I ask you in words, I said, what is the square root of 25? Okay, how can you find the square root of 25? Then you have two solutions. You have 5 and negative 5, because of both 5 and a negative 5, you square, you have 25. Now you see the difference? If I just give you this sign, by default this is positive. Then that you can just write 5. But if I say this in words, I say, what is the square root? Or what are square roots of 25? Then you have two answers. Okay, so this number, this square root of 25, and inside this square root sign, this is called a radicand. Okay, and this is the radical symbol, and that's the root. And sometimes you might have seen this little number 3, which is the cube root, but we're going to do this later. Okay, we're not going to do that today. So today we only do square root. I can write a 2 here, or I just leave it. If you leave it with nothing, by default means a square root. Right. Now let's look at this. Can you evaluate the following. Okay, how about plus minus the square root of 9? You're looking for number, you square it, you get a 9. So the answer is plus minus 3. Okay, so what about square root of 81? Can you find a number? You squared it, you get 81. We know 9 times 9 is 81, so this answer is 9. Be very careful, you don't have negative 9 here, okay? So what about if I ask you negative square root of 49? That will be, you have a negative sign here, so your answer should be negative. So it's a negative 7 because 7 squared is 49. Now, I ask you, please, you just remember the following, okay? 1 square is 1. 2 square is 4. 3 square is 9. 4 square, 16. 5 square is 25. 6 square is 36. 7 square is 49. Okay, 8 square is 64. 9 square is 81. All right, now, and more than that, you write 10 square should be 100. 11 square is 121. And 12 square is 144. And if you want to know a little bit more, so that's 169. And 14 square is 196. 15 square is 225. At least, I hope at least you can remember the square, the complete square of the number from 1 to 15. That will help you a lot in the future when you work on the calculation job, and also make sure that you are very familiar with all those complete squares. If I give you 144, by the time you need to take a square root of it, you know it's going to be 12 right away. Okay, so this is very important. Of course, there's going to be something more if you want to do. It's like a 20 square, it's a 400, things like that. Okay, 30 square is 900. Okay, so those are very, very easy. Those are very straightforward. So this is how you evaluate the square root. All right, now here. Okay. If you use the calculator to calculate a square, you can use your phone. Your phone has a calculator. Let me get my phone here so I can use the calculator. And make sure that you have to use the scientific one because your phone has 2 calculators. And you're going to use the one looks like this. You're going to use the one looks like this. Okay? All right. Now, did you notice here is the square root? This is the square root. It's not very clear. Let me use the blue pen to show that. This is the square root of x. So what do you need to do? For example, if you're looking for the square root of 400, you do 400 square root of it. You get a 20 right away. Okay. So what about if I ask you, what is the square root of 32? So here's a 32, and then you take square root. Ooh, you get this number because 32 is not a complete square. You don't have a single whole number. You square it to get a 32. So you can get a 2.65 something, and that is a number with all the decimals behind. Usually we can round it to the 2 or 3 places after the decimals, but it's not a whole number. That's the square root of 32. How about this? How about let's see, 625 square root. Then you get a 25. So you know 25 square is a 625. So this is how do you use your calculator. Okay. The next one, we're going to talk about What type of real numbers? They're all different type of real numbers. So let me show you this. So all kinds of real numbers. Okay. Now, first thing, you remember that when you are very, very little, the first time you get to know numbers, you probably get people ask you, how old are you? Then you use one finger, show that I'm 1 year old, and then you're 2 years old, and then you're 3 years old, and so on. So starting from 1, and then 2, and then 3, so then you know more and more numbers, right? And all those, we call this natural numbers, because naturally we know these numbers. All right, so I'm going to put them in this box. Okay, and then when you grow a little older, then you find, oh, there is a 0, right? So you start adding 0. Start to add a 0 to all the previous numbers together, and this is called a whole numbers. All right, now the whole numbers. What are the whole numbers? Whole numbers means starting from 0. So 0, 1, 2, 3, 4, 5, 6. They're all whole numbers. You can tell this natural numbers is part of this whole numbers. Okay. And then you get a little bit older again. Then you learn some negative numbers, right? We just did like a -1, -2, -3, and you learn -100 and a lot of negative numbers. So you have not only positive numbers, but the 0 and the negative numbers like this. We called all those integers. Those integers, there is like a 1, which is 1.0. There's nothing after the decimal point. So they are positive and the negative whole numbers together. We call this integers. Is that right? So it gets older and older, you know more and more. And after that, then you start learning fractions, don't you? So you're going to start knowing 1/2, okay, like a -3/5, 11/59. Well, things like this, very complicated, but you get fractions. And those are the numerators, this is the denominators, right? Numerator over denominator. And how do we call this? We call this rational numbers. All right, so everything starting from this. Let me just draw that. The definition of a real number is those are the numbers can be expressed as a fraction. So not only this 1/2, -3/5, 11/59, or maybe 1 over like a 1 and a 1/2, all those are rational numbers, but also this -1, -2, -3, they are also rational numbers, and a 0 is also a rational number. 1, 2, 3, 4, 5, 6, 7, they are all rational numbers. So rational number is really the biggest box here. Okay, so I just told you that all the numbers that can be expressed as a fraction, we call this rational numbers. But you might want to ask, is there any number that we cannot express that as a fraction? Yes. Let me give you one example if you can remember. Pi. Do you remember what is pi? Pi is in a circle, then the perimeter divided by the radius. That ratio is pi. The pi value is a 3 point. That is actually 1.159. So pi is a number that cannot be expressed as a fraction. How about a square root of 2? Now you use your calculator, you look at a square root of 2. Then you're going to notice that square root of 2, here, 2 squared square root. Do you see this number? Okay, that number will keep going because I don't have enough digit on my calculator, but it will continue and on and on and on and on, but never repeat. So that is also not a rational number. We call that an irrational number. Those are irrational number. This is irrational numbers. Okay, now all things together, real numbers are, this is real. Real numbers include rational and irrational. Rational number include all the numbers that's not integers and integers. And integers have a positive, a 0, and a negative integers. Positive integers, negative integers, and a 0. And from 0, 1, 2, 3, 4, 5, that's called a whole number. And then without a 0, 1, 2, 3, 4, 5 is called a natural number. Did you see this relationship? Okay, this is a very important concept. That is the real number. What are the real numbers? All kinds of real numbers, and how do we call them? Okay. So next one, we're going to start working on the compare some real numbers. When we talk about compare the real numbers, we want to compare which one is greater, which one is smaller, isn't it? We can definitely do this. Okay, so we can compare real numbers. How do we compare that? I tell you the tricky part is very easy. We put them on the number line so we can know that immediately. All right, let's work on this. Compare the following real numbers. I go negative 7 over 2, square root of 5, square root of 6.5, okay, and 3, 2.5, negative square root of 8. That's about it. Okay, I have a 1, 2, 3, 4, 5, 6. So we have 6 numbers. So we're going to compare that, which means we need to find which one is greater, which one is smaller. Look at here. We have 2 negative numbers. We have 4 positive numbers. So I draw this number line, and here's a 0. And I know this too. Very easy. 1, 2, 1, 2, 3. So I have a here, I have a 3, isn't it? So that's a 3. And then I get a 2.5 here. That's 2.5. All right, so very easy. And then this one, negative 7 over 2. So I have a negative 1, negative 2, and a negative 3, and a negative 4. Negative 7 over 2. 7 divided by 2 is a 3.5. So that is negative 1, negative 2, negative 3, negative 4, then negative 3.5. Here is this guy. Just show that. Okay, and then we have the other 3 with square root. I know how to do. Have my calculator. All right, let me use my calculator. Use my magic calculator. All right, 5. Let's work on 5 square root first. So 5 square root is 2.23 something. Is 2.2, so slightly less than that. Here's 2.5, so 2.2 is right here. And I can show. I'm a little lazy. I just pointed here. All right. Now, what about a 6.5? Okay, so let me do that. Let me do 6.5 square root 2.5495. 2.5, slightly more than 2.5. So here's 2.5, and then this guy is slightly to the right of it, isn't it? Yes. Okay, what about this one? What about this negative square root of 8? So we do 8 square root to negative 2.8 something. Sorry, negative 2.8, negative 2.8, which is here. Here is negative square root of 8. So far I have a 1, 2, 3, 4, 5, 6. I have 6 numbers. Okay, let me tell you how do you write that. You write from left to right. You get a negative 7 over 2. That's the smallest. It's less than negative a square root of 8. It's less than the next point we're looking for is this, square root of 5. Okay, it's less than, the next number is 2.5. Okay, they're very close to each other, isn't it? And then this point, that is the square root of 6.5. And then the greatest number is 3. See? When I ask you to compare real numbers, this is how you should do it. Okay. Now we start working on the how to add real numbers. Add real numbers. Okay. To add real numbers, let me see, I ask you to remember when we say add, addition, then we can use a plus, sum, and, more than, those kind of keywords, right? Okay, so we can use, you can use number line. You can use number line. For example, if I go from negative 2 plus 5, so this is a real number, this is a real number, and I ask you to add them. So what you should do is you find 0, 1, negative 2, 1, 2, 3, 4, 5. So you're going to start from negative 2, and then when I say add 5, which is a positive 5, then you're going to move to the right. You're going to jump 5 times, 5 units. So 1, 2, 3, 4, 5. There you go. So you stop here. So the answer is 3. Okay. Understand? So this is how do you add. What about if I go negative 2 plus negative 5? Negative 2 plus negative 5. So again, you start from negative 2. But because you're going to add a negative 5, so you're going to jump to the left by 5 units. So negative 3, negative 4, negative 3, 4, 5, 6, 7. So you stop here, and that's negative 7. See, you're starting from negative 2 because you're going to add a negative 5. So you jump to the left by 5 units, so you get a negative 5. You get negative 7. Okay, so this is how do you use the number line to do it. And you can tell that if you want to add 2 numbers, for example, 2 plus 3. Okay, so you can just, starting from 2, and then jump to the right by 3, and then positive number plus a positive number, you get a positive, and then you just add this to absolute value, isn't it? So you just get a 5. Right? Okay, so how about if I ask you to do 2 plus a negative 3, which is 2 at here, but then you're going to jump to the left by 3 units. And then when you jump to the left by 2 units, you touch there and then you have to go further. So the answer is negative. Now, if you compare these two numbers, 2 and a negative 3, this one, negative 3, has a greater absolute value, and that is negative. So the answer will be negative, and you take the difference between these two numbers' absolute values. So go right to 2, and then to the left by 3. So the answer is negative 1. And what about if you go negative 3 plus 2? So start from negative 3 and then go to the right by 2 units. You're not even touched 0 yet. You're still on the left side. So the answer is a negative for sure, because this one has greater absolute value. We just learned the absolute value, right? So, and then negative 3 plus 2, and that is 1. What about a negative 3, negative 2? So it's a negative 3 plus a negative 2. So you go negative 3, and then jump to the left by 2 more units, you get a negative 5. Did you see that? You take whatever the absolute value greater, take that sign, and then you figure out if they have the same absolute value. If they have the same sign, you add their absolute value. If they have opposite sign, then you take the difference between their two absolute values. It sounds very complicated, but once you get familiar with the number line, you just think about it going to the left or to the right, then you're gonna find that should be fairly easy. Okay. So we are going to talk about the properties of addition. This is very important. Properties of addition. Which I didn't finish writing, which is the properties of addition of real numbers. Okay, there are 4 properties. The first one is called a commutative property. What is this commutative property? If I use the letter to show that, that will be this. Would be A plus B equals B plus A. What does that mean? That means if you add 2 real numbers, it doesn't matter which number you write first. For example, 2 plus 3, it's going to be the same as 3 plus 2. You might think, yeah, it's obvious. Of course, right? Because you can see that. The answer is 5, no matter what you do. But remember, this is a property. And later when you work on math equations, or when you work on some other math problems, you can do this. You can switch the order of these 2 numbers because we have this property. Okay, it's very important. All right, now you might think this is common sense. Of course I know it, but remember, this is a property. Later we're going to talk about this. And the second one is called associative property. What does that mean? That means A plus B first, because we have this parenthesis, then plus C, which is the same as we can just add this B and C together in the parenthesis. Then we do A plus that. All right. Now, this is a very interesting property because you're going to add 3 numbers together. It doesn't really matter which 2 you want to add first, and then add the third one, since you're going to do things step by step. The good thing about this is, for example, if I ask you to write 5 plus 7 plus 3, okay? You can do 5 plus 7, which is 12, plus 3 is 15. Or you can do 5 plus, and then you can just add 7 and 3 first. Because 7 and 3 will be 10, so 5 plus 10 is also 15. Do you see? You are using this associative property. All right. Now, the third one is called identity property. Identity property means no change. What does that mean? That means a plus 0 equals 0 plus a. I don't need to write this because we have the commutative property, and that is a, which means if you give a real number, if you add a 0, then it's the number itself. For example, you get -5 plus 0, which is also -5. So that means plus 0, you can just ignore it. All right, you don't really need that. And the last one is the inverse. It's the inverse property. It's opposite, huh? Okay. What does that mean? That means a plus the inverse of it, or you write -a plus the inverse of -a, which is a, and that is 0. So for example, -5 plus 5 equals 0. And usually when we write the expression, we just cancel this out, right? Plus or minus. Why? Because the properties of an addition of real numbers has this inverse property. Interesting? Yeah? Okay. So let's work on some examples. All right. Let's work on this. We work on 4.2 plus a -5 plus 0.8. That's the all the additions, right? So we're going to work on this parenthesis first, which is negative plus 0.8. Of course, we're going to copy whatever we're not touching. Okay, so -5 plus 0.8. Think about it. You jump to -5, and then you go to the right only by 0.8. So your answer is -4.2. Then 4.2 plus a -4.2 is a 0. Inverse property, isn't it? Yes? Okay. So I think that's something interesting that, let's see, how about this? How about if I ask you, I give you a second example. Okay, so -8.7 plus 3.9 plus 1.3 minus 1.3. All right. First of all, you want to do, if you have a plus 1.3 minus 1.3, can you work on this first and just copy this? Yes. Why? There is a reason. So why you can do this? Because you can do something later and then do things earlier. What is that? It's associative property, right? You're doing this. This is associative property. So you can do this is I take the difference between two, and then 8.7 and 3.9, the difference is a 4.8. All right, so this is the answer. Okay, here's the answer. Now, one more thing I want to tell you about this. Negative 8.7 plus 3.9. Okay, so if you don't really like this decimal points, I tell you what to do. You can plus 0.1 minus 0.1. Okay, let me just block this. Okay, the good thing is this is a 0. It doesn't really change the value, but I can combine this. That's a 4, and this, and this. So I have negative 8.8, and then here is a plus 4. Then it's much easier because I only need to deal with the whole number part. So I have a negative 4.8. Okay, this is how do you use those properties. And so far I think that's all about the addition property of real numbers. Subtraction of real numbers, or subtract real numbers, which is the same thing. All right, now here is the thing. If you want to do A minus B, a real number minus another real number, you can change that as A plus the opposite of B. What it means is you're going to change from subtraction to addition. Isn't it interesting? For addition, we have all the properties that we can use, and we're already very good at addition. So subtraction means just minus number means plus the negative, or the opposite of it. For example, 7 minus 5, which is 7 plus negative 5. So we already know that 7 and then jump to the left by 5, so the answer is 2. Okay, so I use very easy numbers to show you what does that mean. All right, now let's work on the next. We work on negative 3, negative 8, which is negative 3 minus 8, which is negative 3 plus a negative 8. So you're changing from subtraction to addition, so that will be negative 11. All right, so what about this? What about a 7.5 minus negative 3? Minus means minus number, you're going to change that into add to the opposite. So minus minus become positive, negative negative become positive. So someone remember that way. But basically what you're using is the definition of subtraction of real numbers, which means you subtract a real number, it's add the opposite of that number. Okay, but once you know this, once you practice a lot, then you probably will think, oh, negative negative becomes positive, which is this. But behind the scene, there is a property you're using. Anyway, so we get the answer 10.5. You might think, well, when I was young, 2 years ago, I didn't know the property. I can still do that. Yes, correct. But now you're older, right? You're the algebra kid. You're the algebra person. You're very good at that. Now let me do one more. Do you know 1/3 times 1/2? I don't know, have you learned the fraction to find the least common denominator? So I just assume you know. Okay, if you don't, let me know, then I can add another section about the least common denominator. So 1/3 of 1/2, the denominator is 3 and 2. For 3 and 2, the least common denominator will be 6. So I write this to be like that, right? And the 3 becomes 6, because 3 multiplied by 2, you get a 6. So 1 has to multiply by 2. You get that. The idea is we're not changing the value, we just change the way we write it. 1/3 is exactly the same as 2/6. Same thing happened to this 1/2. 2 times 3, you get a 6. So 1 times 3, you get a 3. So 3 out of 6, which is exactly the same as 1/2. But the good thing, right now we have two fractions. They have the same denominator. Then we only need to work on the numerator. 2 minus 3, which is 2 plus negative 3. The answer is negative 1. So the answer is negative 1/6. All right. And when we talk about the subtraction, if you probably remember that we use the difference. Okay, they ask you find the difference. Or they ask you the change. Okay, the temperature. Yesterday's high temperature was, for example, it's 65 degree Fahrenheit. That's yesterday. And today is 68. degree Fahrenheit. What is the change? The change, you're going to use the later value minus the earlier value. Okay, so what's the change? What's the temperature change? And that's going to be 68 Fahrenheit minus 65 Fahrenheit. So the change is a 3 degree. Okay, so that's the temperature change. When we talk about the change, we use minus. When we talk about the difference, that's a subtraction. So this is about the subtraction. Now we're going to work on the multiplication, or we call this multiply real numbers. Multiply real numbers. We learned this, right? We know 2 times 4, that's 8. We know negative 2 times negative 4 is a positive 8, isn't it? Negative, negative, positive, you know that? And what about 3 times 2 times negative 5? What about this? 3 times 2 is a 6. 6 times negative 5, I have a negative 30. So I believe you know all of them already. Now, then let me give you maybe just a couple of more example. What about 15 times 0? 15 times 0, that is 0, isn't it? 15 times 0. How about 8 times 1? 8 times 1, that's just 8. What about 4 times negative 1? That will be just negative 4. Okay, so we already know how to do the calculation. The little example here is 8 times 1/4. This is also the real number multiplication, and so that will be 8 over 4, and then, or we can factor this. We get a 2, so the answer is 2. If you know how to do that, you're good. You can continue. If you get confused about that, then please let me know that I'm going to make another class for just the fractions. I believe this fraction, you probably should learn this like a while ago. So let me give you another example, which is a little bit complicated. Okay, 3 over 4, 3/4 times negative 1/3 times negative 8 over 9. So this is the fraction. And then first of all, you find positive, positive, negative, positive, positive, that's positive, positive, negative, you get a negative. And then this 3 canceled out this 3. And this 4 canceled out with this 8, you have a 2 on top, and then keep this 9. So the answer is 2 over 9. So those are some examples about the multiplication of real numbers. All right. Now, next one, we're going to deal with the properties. I'm going to talk about the properties. Again, after we learned the addition, we learned a lot of properties, right? Do you remember how many we did? We did 4. Okay, the first one is a commutative property. The second one is associative property here for the multiplication. And we have the same thing. We have a similar. We have a commutative property. That's a property of a multiplication. For addition is A times B equals B, A plus B equals B plus A. But for multiplication, and that is what? That is A times B is B times A. For example, 2 times 5 is 5 times 2. Okay? And the second one is very similar. The second one is associative property. Do you remember the associative property for addition, that is a plus b parenthesis plus c equals a plus the parenthesis b plus c. So it doesn't really matter which operation you do first, which is the same thing. A times b, we can multiply a times b, and then we times c, which is the same as I do b times c first, then times a. For example, 3 times 2 first times 5, which is the same as the 3 times 2 times 5. Did you notice sometimes I use this cross, sometimes I put dot, which means exactly the same thing. All right, now the third one is identity property. Do you remember the identity property for addition, which is 0 plus a, which is a, means you add something, doesn't change the value. And in this case, we have a times 1, which is the 1 times a. You multiply by something, you don't change the value. So like 3 times 1, which is 1 times 3, which is just 3. So you multiply by 1, doesn't change. That's the identity. And the other one is property of inverse property. What does that mean? Remember, for the addition, we have the inverse property, that is a plus negative a equals 0, right? Any number, add the opposite of it, equals 0. Now in this case, we have the property of we call this inverse. We shouldn't call this inverse. We should call this negative 1. Property of negative 1. That is a times negative 1, which is negative 1 times a, which is negative a. Okay, so this is similar to that opposite. It's just you multiply by negative 1, you get the opposite of it. So 3 times negative 1 equals negative 1 times 3, which is negative 3. Okay, the other one, we have a property of negative 1. We also have a property of 0. That's very different. Property of 0. That means a times 0 is 0 times a equals 0. So 3 times 0, which is times, and that's 0. So it's slightly different than addition. So there are 5 properties. Commutative is the same, associative and identity. For these 3, they're pretty much the same, but for addition we have an inverse property, but here we have the property of negative 1 and a property of 0. Okay, so let me look at some example and find out which property that we're using. Okay, so negative 1 times 5, that is negative 5. Which property you're using? You're using the property of negative 1. Okay, the property of negative 1. All right, now what about this? What about 0 times negative 8? 0 times negative 8 is 0. We're using this. We're doing this because we know we have the property of 0. Okay, so what about negative 2 times negative 3, which is the same of negative 3 times negative 2. So we switch the order of them, and we switch the order. That is a commutative property. Okay, so the next one. All right, the next one. 13 times 2 times 5, which is the 13 times 2 times 5. What property I'm using? I'm using associative property. See, the good thing about that, I know 13 times 2, which is 26. 26 times 5, I got 130. Or I can just do this first. I can do 2 times 5 first. I get 10 times that, I get 130. This is much faster. And the reason I can do this because for the multiplication of real numbers, I have associative property. Sounds good? All right. So what about we have the okay, I have one more. I have a 100 times 1. Oh, that is just 100. What is this? This is the identity property. Okay, so we did reviewed all those 5 properties of multiplication. All right. All right, we learned the multiplication and addition, subtraction. Now there is a very, very important property that we need to know is called distributive property. And this one is not just only for addition or multiplication, it has a combine of both. What is this? That is A times B plus C, which is AB plus AC. See, you're distributing this A to this parenthesis to each of the number. That's why it's called a distributive property. What about this? What about B plus C times A? It's the same thing. We can distribute that into this. Why? Because for multiplication, we have a commutative property. So this one is also AB, and plus AC, we distribute this. So we can distribute the number into the parentheses. What about this? What about B minus C? That's the same thing. You can also distribute it at AB minus AC. And if you have B minus C times A, C times A, then you're going to have AB minus AC. Okay, so you see this is the property, the distributive property. This is very important. For example, I'll give you a couple of quick example here. If I ask you to do x plus 2 times x, then you distribute this into here and here. Okay, distribute. Then you have x squared plus 2x. All right. Now, this. What about this? What about x minus 5 times negative x? Exactly the same idea. You distribute this into that. So you have a negative x squared plus 5x. Okay. So this is a distributive property. Okay. And another interesting example is this. It's negative 2 minus x. You can distribute this negative sign, because this negative means negative 1 times. So you distribute that into the parentheses, you get a negative 2 plus x. So you have to be super, super careful when you distribute this. What about this? What about 1/2 times 2x plus 8? Distribute. So you distribute this 1/2 into that, you get a 1/2 times 2x plus 1/2 times 8. So this 2 and a 2/2 get cancelled out. You have x, and this you cancel, that get a 4. So you have x plus 4. Okay, so do you see that? This is very important. You're going to use this a lot in the future. Okay. Let's see. Maybe I give you one example. It might be a little too early to do that. However, if I ask you to do x plus 1 times x plus 1, or that's x plus 1 squared, right? I just write it like this. I can use distributive property because I can use this as a whole thing and then distributing to here and here. Okay, see what I'm doing? So that will become x times x plus 1, and then multiply by 1 because I have this identity property, so I'm going to have x plus 1. Because I multiply by 1, it's the same thing. I don't need to write that. All right, so again, I use distributive property again. So I have x squared plus x. All right, now this is just a plus x plus 1, and then I combine like terms. These two are like terms. So I have x squared plus 2x plus 1. Okay, because later you're going to learn there's a method called a FOIL method, but we don't do it right now. And right now we just simply use the distributive property to find the final answer. So this is the distributive property that combines plus and multiply, addition and multiply. Okay. We finished the plus, minus, multiply by, and divided by. We're going to do this. We're going to divide real numbers. Divide real numbers. Okay. So divided by 3. Okay. So I will tell you a number divided by 3 is multiplied by the reciprocal of 3. So you're going to do A divided by B, which is A times 1 over B. Here, of course, B cannot be 0. You're not going to divide it by 0, so B is not 0. So divided by a number which is the same as multiplied by 1 over that. How do we call this? This is called the inverse of a number, or we call that a reciprocal of a number, which is the same thing. The inverse, you might want to be very careful with the term inverse. You can call this multiplicative inverse. Okay, so for example, 5 divided by 2, that would be 5 times 1/2. See, 2 and 1/2, they are multiplicative inverse of each other, so that will be 5 over 2. Okay. What about 7 divided by -3? Divided a real number divided by another real number, which we can change that into multiplication and change this to be -1 over 3. Okay. Keep the sign, negative, negative. 3 becomes 1/3, because when you want to divide it by and then change it to multiplication. So that answer will be -7 over 3. Okay. What about -8 divided by -8? That would be -8 times -1 over 8. 1 over 8. And the negative becomes positive, and 8 and 1/8 cross out, so you have 1. Of course, 2 divided by 2, you can tell right away, right? You learned this long time ago. 2 divided by 2 is 1. Or you can write 2 times 1 over 2, that is 1. Okay? So this is the division, divided by the real number. Okay, divided by the real number. We're going to work on a little summation of A and B. Okay, so A plus B, A minus B, A times B, and A divided by B. Okay. If A positive, b positive, then a plus b for sure is positive, right? A positive number plus a positive number is positive. What about a minus b? It depends. If a is greater than b, then it's going to be positive. If a is less than b, then the answer will be negative. A times b is positive, a divided by b is positive. Okay, so what about a positive, b negative? Then a plus b depends on the absolute value of a is greater than the absolute value of a b. We have a greater positive number, like a positive 5 minus a 3, so that becomes positive, and otherwise it's negative. Okay, if a less than that, then it's negative, and if a is equal to absolute value of b, and then that answer is 0. See that? Okay, so a minus b, a is positive, b is negative, minus negative number becomes a plus a positive number, so this one for sure is positive. So let me just make sure that I do this. Okay. And then a times b, positive, negative, you get a negative. A divided by is negative. Alright, so that's how you determine the sign. I'm not going to finish this because next you can put a negative and b positive, and you can also put both a and a b negative. You can finish this chart. But I really don't like you to remember the charts or the formula. I like you to do a little bit of exercise and really understand it, so you don't really need to remember the tables. I think that's all everything I need to tell you about everything about the real numbers. This is the second class of the Algebra 1. I hope you like it and getting ready for the class of 3. And I think if you go to your textbook that you're using, you're going to find plenty exercises and you can practice it. If you forgot what to do, then you can always come to my video to listen to that part. I have at least the time and which section in this class, so you can just go directly to that part to listen again and to understand. Okay, hope you like it, and let's get ready for our next class. Thank you.